Hello guys, my name is Branko. I'm a creative road manager here at MikroE, and today, during this webinar session, I will try to explain how you can run wireless weather monitoring solution with the help of the Arduino development board and of course the NECTO Studio over there. Okay, yeah, you heard me well. Arduino development boards are supported within the NECTO Studio, and you will be able to connect to one of them remotely, and you will be able to taste the weather station solution by yourself. There are three things that you have to perform. Number one, run the NECTO Studio, obviously. Number two, remotely connect to this development board from within the NECTO Studio itself. And number three, download and flash already developed code solution for this wireless weather solution with the Arduino development board. Okay, and you may be wondering how the solution is going to look like. Well, this is how I have used this complete solution. I have managed to translate all the data to the browser, and I'm able to visualize all the data in real time. This is the final outcome of this complete solution and this webinar as well. Okay, I'm able to visualize the humidity of the weather station, and I am able to visualize the temperature with the help of the Arduino based weather station. Okay, and now let's start recreating the complete solution. So I'm going to start with the hardware setup in the first place. I'm going to create a hardware setup for the Arduino Mega 2560 development board, because I have used this board to get up and running with this Arduino based weather station solution. Okay, so I need to transfer myself to the NECTO Studio right now, and just give me a second. Okay, and here it is. Here is the NECTO environment, and the next logical thing that we have to perform is the creation of setups. There is one note over there, guys. We have developed a guided tour for the creation of hardware setups, so you can run guided tour with the help of the help action item in the upper part of the NECTO Studio, and after that just click on the start guided tour, and here it is. Here is the guided tour, which is going to help you create your first hardware setup. Yeah, you can press show me, perfect, and after that this guided tour is going to navigate you to create your first new setup. Okay, I'm just going to end this tour right now, and I'm just going to create the hardware setup which is important for this current webinar session. Okay, so I'm just going to jump into setups wizard right in the NECTO Studio, and I'm just going to click on the next, and here it is. The first thing that we have to configure is the compiler selection. So I have to select because we are dealing with the AVR development board, AVR microcontroller, I'm just going to select the AVR compiler. So I can just press enter, and the wizard is going to lead me to the next selection that I have to perform. The next selection is the development board selection, and here it is. 1, 2, 3, 4, 5. 5 Arduino development boards are currently supported within the NECTO Studio. I'm going to stick with the Arduino Mega development board, because I have used this particular development board, this one, to place it in the Planet Debug feature, which you will be able to connect to just after this webinar session ends. So, okay, I have selected Arduino Mega 2560 revision 3. Click enter, and here we are. The next thing that we have to perform is the microcontroller selection. For obvious reasons, AT Mega 2560 is already pre-configured and pre-selected, because this microcontroller is basically on board this dev board. So yeah, the clock is already pre-configured, so you do not have to do anything. Just press enter. Okay. The next thing that we have to perform is selecting a display. This development board does not have any display whatsoever, so I'm going to stick with the no display. And the last thing that we have to perform is selecting a programmer debug device. I'm going to stick with the code grip programmer debug device because of the two reasons. Number one reason is that the code grip programmer debug device, this one over there, is basically built in within the NECTO Studio itself. So I want to make use of the code grip programmer debug device because of that. The number two thing is that the code grip is Wi-Fi capable programmer debug device, which is going to help me remotely connect to a development board over there. So there is one thing that we have to perform, though, because I'm going to use the code grip device. I'm going to use the programming headers over there, which are over there, and those programming headers are the in-circuit programming headers, and I'm going to use this one, those 6 pins over there, to connect code grip device with the Arduino development board. So please make sure to jump into target options over there and to select the in-circuit programming as a default programming protocol, and after that I would stick with the 2 MHz speed of programming, and I will not be needing the verification of the after we have written the code into my controller, because this is the webinar session and the verification can last a little bit, so I do not want to waste your time. So this is why I'm going to disable the verification. Okay, after clicking save, we can finish this particular setup, and the NECTO is going to configure everything in the background. While NECTO is configuring our first hardware setup in the background, I'm just going to switch to myself once again. Okay, perfect. And I want to explain why am I going to use and how am I going to use the ISP headers to program the microcontroller. Okay, just give me a second. I'm going to switch to the Firefox right now. Okay, perfect. And yes, here it is. Here is the code grip programmer debug device, and here is how you will be able to connect the development board, Arduino development board, with the code grip device. Obviously, use one of the ground pins. Use 3.3 volts pin. Okay, you're definitely going to connect the clock pin and the data pins as well. And after that, please make sure to connect the reset pin as well. And how are you going to connect this header, this programming header, with the Arduino development board? And here is how. Here are the pins that you have to connect code grip and Arduino with. Here they are. Okay, 1, 2, 3, 4, 5, 6 pins on the Arduino development board. 6 pins that you have to connect the code grip with. Okay. Now that we have straightened that out, I'm just going to get back to the NECTO Studio right now. Okay, perfect. Here it is. Here is the hardware setup, which we are going to utilize to flash the microcontroller ATmega2560 on the Arduino development board in order to get the wireless weather station solution. I do not like those default names for hardware setups, so I'm just going to give it some logical name. And yes, we are done. We are done with creating a hardware setup. So this means that I have basically created and explained a scenario, number 1, basically, in which you guys, if you have Arduino development board, write at your home, at your office right now, and if you have code rip device at your home as well, I have covered this scenario right now. So you basically connect code rip and Arduino development board, and you are ready to go and flash a microcontroller with the help of the NECTO Studio, obviously Arduino Mega development board, and the code grip programming debug device. Okay, that was the first scenario. The second scenario that we have to cover is the remote connection to a development board, which we already provided to you guys. There is one keynote over there, important note over there, because I'm going to use the setup that we have just created. I'm just going to go into File, then NECTO Preferences, then General Settings, and I will make sure that always use default Planet Debug setup is unchecked. So make sure that this one is unchecked. And why is that? Well, because we are using the ISP in circuit programming or programmer protocol, we want to make sure that we are using the hardware setup that we have created right now, and we want to make sure that this setup will be the default setup for the connection to the Planet Debug hardware. Okay, and where is that Planet Debug hardware? Where is that Arduino development board which is remotely connected? Here it is. You just have to jump into the section which is called Planet Debug. And what the Planet Debug is, well, it is the Planet with a lot of development boards available to you, 127 development boards to be precise, and all of them are available to you with some pre-default default configuration setup already configured to you guys. So we have inserted some clipboards that you can utilize free of charge once again. So jump into the Planet Debug setup and just try to search for the Arduino. Here it is. Here is the remote Arduino Mega 2560. Yeah, it is simple yet effective setup. So yeah. So here it is, guys. Yeah, you in essence you cannot see the Arduino Mega 2560 development board because of something which we do call shield. So it is click shield for Arduino Mega, which is going to help me insert some add-on boards, some clipboards. So in essence, yeah, Arduino development board, and I have placed the shield onto Arduino development board. And after that, I have placed the clipboards on the shield. And that's basically it. This is the hardware setup that I'm going to utilize in order to get the wireless weather monitoring solution to you guys right now. So, and yeah, and one pro tip over there, make sure to use the external power supply with which can provide a significant amount of milliamps or amps, should I say. Yeah, that is a pro tip, because we want to get a sustainable hardware setup. Okay, first thing, you may be wondering, well, we have already some clipboards, some add-on boards over there. Can you explain what those clipboards are going to perform? Yes, I can explain. Okay, I can explain the first one, the Barometer 7 clipboard over there. And I'm going to explain it by jumping into the package of software package of the Barometer 7 clipboard, and I'm going to jump into the package manager to download the Barometer 7 software package. Okay, after the installation of the software package, I will be presented with two things: the software library for the Barometer 7 clipboard and the code example for the Barometer 7 clipboard. And here it is. Here is the simplest example for the Barometer 7 clipboard. This example is going to perform two things. The first thing is going to be the application initialization part, and the second thing is going to be for obvious reasons, the application task. The application init is going to perform the in essence the SPI configuration of the ATmega2560, because barometer 7 clipboard is going to utilize the SPI communication of the ATmega2560 in order to get the information, the data. And what is the data? Well, the data is going to be collected within the application task function, and the application task is basically going to retrieve two things: the current pressure and the current temperature. And of course, we are going to utilize the logging. So basically what you can do is use the transmit and receive pins of the Arduino Mega 2560 development board, UART transmit and receive pins of this development board, and just jump into the tools section and jump inside the UART terminal and connect to the UART terminal, and you will be able to visualize the temperature and the pressure values with the help of the UART terminal as well. So that's another feature of this click example. Okay, I think that I have explained the barometer 7 clipboard. Okay, now I can explain the next clipboard, which is on the Arduino Mega 2560 development board. The next clipboard is basically the Calypso clipboard, which in essence is going to help me wirelessly send the temperature and humidity data to the TCP server. Okay, and where can I get the code for the Calypso clipboard? Once again, you just jump into the package manager, try searching the Calypso clipboard, and after that the installation is going to proceed. After the installation, once again we are going to get two things: the software library for the clipboard and of course the example for the clipboard. This one is going to be a little bit more complex one for obvious reasons. We are dealing with the Wi-Fi communication, so TCP, and in some other cases UDP communication as well. And in essence, what this clipboard is going to perform, it is going to create a connection to the TCP UDP echo server, and then it is going to send a message to read it back, and that's basically it. I'm not going to use the TCP UDP echo server per se, so I'm going to use the TCP server basically with the Python scripting, and that's it basically. Let's see how this example is going to perform. So just give me a second, and here it is. Here is the Calypso example functionality, which is going to open the TCP and UDP protocols by creating a TCP socket. After that, it is going to connect to the TCP server, and after that we are going to send the data to the TCP server. Of course, we can read data from the TCP server as well, and then we are going to close the TCP connection. Practically the same thing is going to be performed with the UDP socket and UDP connection. One note over there: I'm not going to, once again, I'm not going to use the echo server. I'm just going to use the plain TCP server in order to get the temperature and humidity, and I'm not going to utilize the UDP logic as well, just the TCP logic. And finally, guys, you may be wondering, where is the complete solution? I basically showed you the example for the barometer 7 clipboard and the example for the Calypso clipboard. Those two examples are separate examples, but I have created a complete code solution by basically combining those two. I have combined the barometer 7 clipboard and the Calypso clipboard in order to get the wireless weather station solution to you guys right now. So where can I get, or where you can get this complete solution? Once again, for the it's completely logical. Just jump into the package manager and search for the wireless weather monitoring solution. After the installation of this weather monitoring solution, you will be presented once again with the example. Yeah, I'm going to use this hardware setup once again, and here it is. Here is the complete wireless weather monitoring solution for the Arduino 80MEGA2560 development board. Yeah, let me just show you how am I going to send the temperature and humidity data. Just give me a second. Okay, here it is. Here is the application task, and inside the application task I'm going to get the pressure and I'm going to get the temperature, and after that I will just translate and transmit this data, the pressure and temperature data, with the Calypso clipboard, which is a Wi-Fi based clipboard. So here it is. Of course we are going to perform the translation, so conversion from the unsigned integer 16 to the string, and after that we are going to perform the concatenation inside the message content array. And once again, this is the pressure, this is the temperature, and here it is. Message content had been configured, and after the message content had been configured, we are going to perform the TCP socketing, the connection, and then we're going to capture the length of the message, and finally we are going to send data to the TCP server. Okay, and in essence this is how the wireless weather station solution is going to perform the task. Okay, I'm just going to make sure the nothing is programmed on the microcontroller. I'm just going to press erase, and I have just made sure that this current setup does not have any development code in it. So because I made sure that the microcontroller is empty, I'm just going to flash this particular code into the microcontroller. Okay, it is programming. Perfect. I'm just going to switch to the Firefox right now. Just give me a second. Perfect. And here it is. Let's just refresh it. Okay. And I'm just going to capture the temperature. Okay, 25 degrees. Okay, guys, perfect. Okay, guys, you may be wondering, how do I get all of those data from within the remotely connected development board to the this graphical interface that I just have showed you? Yeah, basically what we have is we have a Calypso clipboard which is going to wirelessly send the data. And what is the data? The data is the data which had been collected from the parameter 7 clipboard, and that was basically the temperature and the humidity. So we have temperature and humidity data, which we do send with the help of the Calypso clipboard wirelessly to something. And what is that something? Well, this something is the Python-based TCP server. And I'm just going to show you something right now. Just give me a second. Okay, here it is, and okay, just give me a second. Perfect. Here it is, guys. Here it is. On the right corner, you will be able to see how do I get the data with the help of the TCP server. Okay, and you can actually see the three or four things. Connection established with something, you can actually see some you can actually see some things over there. The information is basically the connection established with the IP address and the particular port. After that, what is the received data, and after that there is information about there is information which is going to help us understand that the data is successfully sent to InfluxDB. And the final thing is the no more data from client, closing connection. Okay guys, a lot of things are happening over there, so just give me a second. I'm just going to focus myself on the NECTO Studio right now. Okay, here it is. Okay, I have just explained the logic, the TCP logic, the TCP transmitter receiver logic, but I would like to explain it a little bit more. So I'm just going to create a new file over there because I want to explain how did I get the data. So just give me a second. TCP server.python. Okay, here it is. I'm just going to copy the information. Just give me a second. And here it is, guys. Here is the TCP server Python script that I have run within the Docker environment. And one pro tip over here, guys. Do not try to utilize the Docker instance right away. In order to get the initial results, I have created a local TCP server Python script, which I basically run on my laptop, on my Ubuntu laptop. And after that, when I got the initial results on my laptop, then I have created a Docker environment. And this is why you have seen the terminal output a minute ago. This terminal output was the output from the Docker instance. Okay. And now I would like to explain the TCP server Python script. Okay, let's start from the beginning. Import socket and import requests. Socket, it basically manages network connections, and the requests basically sends HTTP requests. It is going to help me write the data to InfluxDB instance. And InfluxDB instance is basically a database. That is basically what you have to know about the InfluxDB. The next logical thing I would like to focus over there in the start TCP server function. So I would like to focus on the start TCP server functionality. And yeah, it is the logical thing. So we are going to start the TCP server, and we are going to perform some things over there. We are going to open the 7070 port, port number 7070. One note here, guys, you can use any port, whichever port you want to utilize, but make sure that this port that you're going to utilize for the TCP server is available to you inside your network, local area network. So, okay. That is the first thing that we have to perform. The next thing is the listening. So I intentionally want to allow just only one connection at a time. So this is why we have this part of the code, server socket.listen1. Okay, after that we are going to get the client address, and we are going to establish the connection, and we are going to print the IP address of the client, which you already saw. You already saw the IP address within the PuTTY connection that I have established, and I have just showcased a minute ago. Okay, after that we are going to receive the data, and we are going to try to decode it, and yeah, we are going to try to write to Influx database. Okay, and yeah, we can explain the write to Influx functionality right now, and here it is. In essence, we are going to send a valid data to InfluxDB. Yeah, we are going to send the humidity and temperature. After that, we are going to pack it in some kind of package, which we do call payload. And after that, we are going to send this data or post this data with the HTTP post request. And if it is a success, you are going to print the data successfully sent to InfluxDB. Okay guys, that was the TCP server Python script that I am running within the Docker instance. Please make sure that you test the complete solution in the local environment first. Do not utilize the Docker instance. Just make sure that you get the initial results on the local PC, so Ubuntu, macOS, whatever. Okay, that is one thing. The second thing that I'm going to emphasize: make sure that you perform the port forwarding. Yeah, you will have to perform the port forwarding on your router at your home, at your office, to get the TCP server the information that it needs. So yeah, that's it. Okay, the final thing that I have to explain to you guys is the graphical interface, or basically how did I get the temperature and the humidity data visually represented in the browser. So just give me a second. And here it is. Once again, we are looking at the graphical user interface, and in essence, I'm using the open source solution, which is called Grafana. And inside Grafana, you can say, and inside Grafana, you can utilize the SQL language, like over there, to perceive the data as the way that you want to perceive it. So, okay, I'm going to explain this code over there. Just give me a second. Okay, here it is. Yeah, just focus on this part over there. The code I entered is a Flux query for querying data, but I think I'm going to switch myself to native SQL in one of the future releases of this complete solution. And why is that? Because if you visit the Flux website, there is an info about that Flux is in the maintenance mode, and it is not supported in other Influx database instances, in Influx database 3, due to the broad demand of the native SQL and the continuing growth and adoption of the InfluxQL. Yeah, those are their words. So I think that I'm going to switch myself to some native SQL language, maybe in some of the future releases of this complete solution. Okay, let's try to explain this simple code. Okay, from bucket, NECTO bucket, I have basically specified the data source, and the NECTO bucket is the name of my data bucket, which is defined in the Influx database instance. Yeah, please make sure to know that. Okay, the next thing is the range command. Range command is going to set the time range to the last 24 hours. Okay, and we have some filtering over there, right? The first filter is going to filter the data based on conditions. It is going to keep only data points where the measurement is labeled weather. Okay, and the next filter is going to narrow the data down even further. So you're going to get the temperature or humidity, and it is going to keep only the temperature and humidity fields, discarding everything else. And the last thing, yeah, it's obvious, we are going to return the result for visualization in Grafana. And this is in essence how you perform the wireless weather monitoring solution with the help of the Arduino Mega 2560 development board, code grip device, code grip programmer debug device, and the NECTO Studio. And that will be it, guys. I couldn't wait for the question and answering session to begin, so please do ask anything. You can ask anything about this particular solution. You can ask anything about the NECTO Studio. You can ask about SDK inside NECTO Studio. And you can ask about code grip programmer debug device. Yeah, anything really. And without further ado, there is one question in queue. So the question number 1 is from Oliver. And thank you, Oliver, for asking this question. It's an awesome question. And the question is, what if I built this complete solution and I'm not seeing any data in Grafana? What should I check? Well, this was exactly the same scenario I had. So do not worry if it happens to you as well. Just make sure the Arduino is properly flashed and the TCP server is running, and the Influx database, InfluxDB, is correctly configured with the right token and the URL. And to explain it a little bit better, okay, number 1, do not forget to check the main.c file from the solution I provided. And as a matter of fact, I'm just going to transfer myself to NECTO Studio once again. Just give me a second. Okay, here it is. Here it is, NECTO Studio. Okay, yeah, here is the wireless weather monitoring solution. And here are the 4 things that you would have to configure, those over there. So you would definitely have to configure the TCP server address, because you will not have the same IP address as I had. And you will have to configure the TCP server port as well. Of course, Wi-Fi SSID and password are definitely not going to be the same as well. So please make sure to configure all of those things by yourself. And one pro tip over here, guys, I could actually configure this remote IP and remote port definitions by using the local private IP addressing range. So as you can see, this is the this is not the private IP address. This is the public IP address of my company, and you can definitely use something like this. I'm just going to show you. You can definitely use the private IP address just like that, and the port 7070, as you could remember. Yeah, perfect. After building, I could definitely program this example and it could work. So please make sure to check out these remote IP and remote port settings. Okay, that was the number 1 thing that you should check. The next logical thing that you should check is the let me just okay, the next logical thing that you would have to check is networking. Ensure that the TCP server is running and listening on the correct IP address and port. Okay. Okay, that would be the second thing that you would have to check. The next thing you should definitely check is the Influx database configuration. Okay, just give me a second. I'm going to focus on the Firefox once again. Perfect. And I'm going to show you. Oh, okay. Just give me a second. I am going to log in once again. And here it is. Yeah, perfect. Okay, here is the Influx database instance that I already have in my Docker container. And there are several things that you should definitely check. The first one
is definitely API tokens. Make sure that you have the API tokens generated, and you can generate API tokens over there. I already have one, this one, and unfortunately I provided I provided all access to this particular API token, and this is not the common practice. So make sure to customize the access for each token that you configure. The next thing that you would have to perform is definitely a bucket. You need a bucket in the Influx database instance in order to properly send the data from Arduino development board to database, and from database to the Grafana user interface. Okay, and here it is. Here is the NECTO bucket. And by the way, you could definitely see the information, the humidity and temperature information from here as well. And here it is. Here are the live temperature and humidity values: 27 degrees Celsius and 993 millibars. Okay. Okay, just give me a second. I'm just going to focus on the next thing that I have to answer, and that would be the fourth thing that you should definitely check. The fourth thing is Grafana configuration. So make sure to go to Grafana user interface and make sure that data sources field is populated with the particular Influx database. And here it is. Here is the Influx database. And these are the common parameters that I have configured inside the Grafana. Okay, and I think maybe the last thing that you should definitely check is if you are going to use Docker container, please make sure that you check that the containers are actually running, and you can actually check the logs to catch any errors. Okay, I'm just going to transfer to myself right now. Okay, here it is. And I think that I have answered your question. So thank you, Oliver. And I'm going to transfer myself to answering another question. And the question number 2, let me just check. Okay, question number 2 from Oliver once again. Okay. Oliver asked, can I use an Arduino board other than the Mega 2560 with NECTO Studio? Yes, you can. NECTO Studio supports various Arduino boards. For example, Arduino Uno, here it is. Here is the Arduino Uno, and here is the click shield that we already have. So you can basically use Arduino Uno as well. And you can easily mount any clickboard by the microbus socket. Okay, there are Arduino Leonardo, Micro, and Nano. And while these boards do not have a native microbus slot, you can still connect clickboards using jumper wires and a breadboard for prototyping. Okay, and I think that I have answered your question once again, Oliver. So thank you for asking this question. And let me just check once again another set of questions. Okay, the question. Oh, thank you, Anthony. Anthony asked myself, can you show how to flash that barometer sample to the Arduino? Yes, I can show you that. Just give me a second. Okay, just give me a second, and okay, I'm going to transfer myself to NECTO once again. Okay, perfect. Here it is. Because you wanted to download and flash the Barometer 7 click package, you have to go to the package manager and search for the Barometer 7 clickboard, and here it is. Here is the Barometer 7 clickboard. And yes, I already have it installed because I have used the Barometer 7 clipboard for this particular example. So you would have to install it, and then you would have to open the example. And here it is. I have opened the example, and there is one important note over there, Anthony, and that important note is make sure to properly configure the microbus setting over there. So you have to properly configure the mapping of the microbus slot with the Barometer 7 clipboard. Over there we have a microbus 1 definition, but this is not correct. For our project, this is not correct. And I'm going to show you why it is not correct. I'm just going to go to Planet Debug feature, and as you can see, Barometer 7 is not on the microbus 1 slot, but it is on the microbus 2 slot. So in essence, you just have to switch microbus 1 to microbus 2, and after that, after building, you could flash the example, and yeah, that would be it. Okay. And I think that I have answered your question as well, Anthony. So thank you, and please do ask anything that you want. Okay. There is one question once again. Bob Hunt. Okay, thank you, Bump. So Bob is asking, hello, where can I find various compiler switches? For example, which compiler is selected on or other definitions at compile time, microC core version or others? Okay, cool. Thanks for asking that question. So where can you find various compiler switches? For example, which compiler is selected or other definitions? Okay. There is one thing that you can do. I'm just going to show you. Just give me a second. Okay, cool. So compiler switches. The first thing that you could check for compiler switches is just give me a second. Okay, you just go. You just navigate yourself to the lower right side of the NECTO Studio, and you press over there. Okay, and after that, you would have to go to the edit section of this particular hardware setup, and here it is. We are in the compiler section of this current Arduino setup, and the next logical thing that you want is jumping into advanced options of the compiler. And because we are dealing with the AVR compiler, you just click over there, advanced options. And here are some kind of switches that you asked for. Okay, yeah, in terms of the library settings, you definitely could select SDK version of the library that you would like to use for this particular setup, and you would definitely can utilize the bare metal logic as well. Yeah, just something like that. Okay. The next thing that I can explain to you is basically how would you use the standard output? Are you going to redirect standard output to the application output, or are you going to redirect standard output to the UART pins of the Arduino development board? So yeah, that is another switch as well that you asked for. Okay, I have configured this particular setup for the application output. Okay, and the next thing, when we are in the SDK version of the library, all the libraries for the Arduino Mega 80 Mega 2560 microcontroller, there is some nice feature which is called flatten GPIO. Are you going to, so basically in essence, are you going to go with the high speed in terms of the GPIO toggle, or medium or low, or you're definitely going to disable this feature? Okay, cool. That is one thing that I wanted to show you. And the other thing that I wanted to show you is, yeah, you can basically, if you want some other kind of switches, CMake switches, you should definitely perform the following. Right click, focus yourself on the project explorer, and then you should perform the right click on the project that you have selected, and after that you select the change project configuration. And here are the compiler / CMake switches, a lot of them. And yeah, it's basically a key value pair, so you could change anything that you want, anything literally. Okay, and Bob Hunt, thank you for that question. That was an awesome question. I'm glad. I think that I helped you in terms of this question. And okay, let's go ahead. Oliver, once again, Oliver, thank you for giving another question, providing another question. And that question would be, why do we need to run a TCP server? And can I run Grafana on my local machine instead of through Docker? Great question. Great question. So just give me a minute. Just give me a minute, Oliver. And okay. So the question number 1, can I run Grafana on my local machine instead of through Docker? Oh, sorry, that was the question number 2 that you asked. So, okay, I'm going to focus on that right now. Yes, you can install Grafana locally, and I do prefer that option in the first place. Let me just focus on myself. Okay. Yes, that's for sure. So you can install Grafana locally, but what I did is basically I have installed the Grafana, the Influx database, and the TCP server on my local machine in the first place, and after that I have used Docker, which basically simplified the setup process, and it ensures the consistent results across different environments. So that was the question number 2 for you, and now I'm going to return to the question number 1, and that would be, why do we need to run a TCP server? Great question, once again. Yeah, because I wanted to provide wireless weather station solution to you guys. I needed wireless transmission of data, and the Calypso Click is a Wi-Fi based click. And this clickboard in particular, it requires a TCP server for proper operation. So in this setup, the TCP server acts as a bridge, receiving sensor data from the Arduino development board, and then it forwards it to the Influx database for real-time visualization in Grafana. And this is why I needed a TCP server, to visualize the data I have received from within the Arduino weather station. Okay, guys, I think I have answered once again your question, Oliver. Okay, and there is another question. Nice. Okay, Edward. Thank you, Edward, for asking this question. So Edward is asking, hey, you modified earlier from Microbus 1 to 2, but if other protocol is used, SPI, what do I have to modify? I ask this for projects where I do not have microclicks. Okay. So once again, but if other protocol is used, SPI, what do I have to modify? Great question, Edward. So just focus on myself. Okay, cool. Yeah, I have configured the Microbus. I have switched from Microbus 1 to Microbus 2. But if some other protocol is used, SPI, I2C, or some other protocol, what do you have to modify? Well, and you are basically asking this because if you are not going to use micro clickboards, so we call them clickboards. Yeah, you should definitely do something like this. I'm just going to show you right now. Let me just focus on the NECTO Studio once again. Okay, here it is. Okay, I would suggest to you to, for example, you're currently in some project and you would like to utilize SPI, I2C or some other protocol. I would suggest to you to jump into the library manager over there and go and select the software library that you definitely need. For example, you should definitely click on the SPI library over there, and yeah, you could copy the include over there, and after that, let me just okay, just give me a second. Okay, perfect. And then after that, you would definitely include the SPI library over there, and that would be it. That would be it. So once again, to answer your question, if other protocol is used, you are definitely going to go to library manager, jump into library manager, enable that protocol, SPI, I2C, PWM, ADC, UART, etc., and then you just include that header file. And you do not have to rely on the functionalities that we have developed for each particular clipboard. And yeah, I think I have answered your question, Edward, as well. So if I haven't answered your question, please do ask once again, and I would be glad to answer in a different kind of way. Okay, let me just check once again for some other questions. Okay, I'm going to transfer to myself once again. Okay, and I need more questions, so guys, please do ask. And while I'm waiting, I want to promote all the webinars I have scheduled to you guys, and just give me a second. Transition to Firefox once again, and yeah, here are the NECTO webinars that I'm going to provide to you during this year 2025. So please check them out. And the next thing is going to be about the legacy IDE, and please, if you think that there are better subjects for the webinars, please write them down right now, because I'm going to consider that. That's for sure. So the times have changed a lot in the previous 2 years in terms of the artificial intelligence, which means I think that I will incorporate something about AI in embedded industry. So I'm just going to check whether there are some other questions for you guys, from you guys. Okay, no questions. Come on, ask me anything that you want. Okay, no further questions. No further questions. Okay, there is a question. Okay, nice. Another question from Bob Hunt. Hi, where is the definition defined micro C? Oh, great question. Yeah, I will definitely have to get back to in terms to this question. Yeah, understandable. And that is understandable. Yeah, I will definitely have to get back to you, so you can definitely leave me some account or Gmail account or whatsoever, and I'm definitely going to answer to you. Okay, some more questions. I'm just going to wait for a bit. Come on, guys, some more questions. Okay, once again, Bob, I use these switches when changing from GCC to AI. Okay, cool. I'm definitely going to answer that question after this webinar session ends. Okay, some more questions? I think that would be it, guys. Okay, and let me just check once again. Are there any more questions? No. Yeah. Okay, without further ado, I will definitely end this webinar session right now, and I'm going to answer those questions a little bit later. So thank you, guys, and I'll be seeing you once again.